Now here in this question, it is asked that an electric field is applied to a semiconductor. Let the number of charge carriers be n and the average drift speed be v. If the temperature is increased, then what will happen to these factors n and v? The options are both n and v will increase, n will increase but v will decrease, v will increase but n will decrease, both n and v will decrease. To solve this, we'll first see the factor of number of charge carriers n. So here in this figure, the crystalline structure of silicon atoms is shown, where we can see the covalent bonds made by the valence electrons of various silicon atoms. And when the temperature is increased, a few valence electrons which are having the covalent bond with their adjacent atom valence electron will break and come out. So here you can see in this figure, here you can see this valence electron which was here making the covalent bond has come out and has become a free electron here. This has become a free electron, and the place from where this electron has come out, that place will be assumed as a hole. This will be assumed as a hole, and this will be the free electron. Similarly, here you can see even here the electron which was here has come out and become free electron here, and this place from where this electron has come out will be assumed as a hole. So even here you can see the electron has come out, this has become a free electron, and the place here will be assumed as a hole. Even here you can see this is the free electron, and this is the hole. Okay, and here also you can see this is the free electron, and this is the place from where it has come will be assumed as hole. So as a conclusion here, we can say that when temperature increases, a few free electrons which were having a covalent bond with their adjacent atoms valence electron has become free, and the place from where these free electrons have come out, that place will be assumed as hole. So number of free electrons and number of holes will increase. That means as temperature increases, the number of charge carriers, electrons and holes will increase. So this is the first factor, that is number of charge carriers will increase. So here we can see, we can conclude this. As we increase the temperature, additional electron hole pairs are created in the semiconductor. As a result, the number of charge carriers n will increase. Now here, next we will see the second factor, that is the drift velocity. Now let's consider a diagram of semiconductor in which when the increase of temperature is there, we can see a lot of free electrons and positive ions. So here you can see the free electrons as shown here. These are the free electrons here. Here you can see electron. These all are free electrons. And here you can see the positive ions. So free electrons and positive ions are present in the semiconductor when there is increase in temperature. Now all these free electrons are randomly moving and they don't have a direction. Now if the electrons had to move in a specific direction, then an electric field should be applied to it, and then this will look like this, where you can apply this electric field here. This is the electric field E. This is the positive terminal of the field, and this is the negative terminal of the field. Now this field is applied over here, and we can see that when this field is applied, the electrons will be attracted towards the positive terminal of the battery. Okay, so the electrons had to move to the positive terminal of the battery. So all these free electrons will start moving towards the positive terminal of the battery. Now in this movement towards the positive terminal of the battery, say we consider this electron here. Now this electron, when it is moving, it collides with the positive ion. So here again it can go here and it can collide here. So again, while coming from there, it can collide here. Again it can collide here. Again it can collide here. From here it can go and collide here. So this movement will take place with collisions in between. So the free electron, when they are moving, they collide with the positive ions, and with this collision the movement takes place. Now in this we can define what is a generally drift velocity. So here we can see drift velocity. When the free electrons move, they successfully collide with the positive ions of the semiconductor material. At each collision, the free electron loses the extra velocity gain, and then consequently the free electrons move towards the positive end with a small constant velocity. This constant of velocity of free electron is known as the drift velocity. Now, with this general definition of drift velocity, we'll go to see the concept of what is our relaxation time. Now, here again, we can see this diagram of semiconductor. So here, with the application of the electric field here, we can see the movement of electrons, where electrons will be attracted toward the positive terminal of the battery. Let's consider this electron. Now, this electron starts moving, it gets collided here. Then from here, it can get collided here. From here, it can get collided here. From here, it can come here. It can get collided with this positive ion. It can get collided with this positive ion. Again, it can go here. It can take a diversion here. Again, from here, it can take a diversion here. From here, it can go there. From here, it can come here. From here, it can come to this positive ion. It gets collided here, again here, again here, and then it can go to the attraction moment towards the positive terminal of the battery. So here, this can be the moment of electron, the free electron, when it is colliding with the positive ions in the semiconductor. Now here you can see this is the first collision here, and this is the second collision here. Now this collision time, you can take it as T1. T1, this is the time taken for the first collision. The second, this collision and this collision, the consecutive this, you can take it as T2. The third, between this collision time, you can take it as T3. The fourth, this you can take it as T4. The fifth, you can take this as T5. This T6, T7, T7 here, T8, T9, T10, T11, T12, T13, T14, and this is T14. So these are the collision times. Now if you take the average of this, say for example it is T1 plus T2 plus T3 plus dot 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 T14 upon 14. So if you take this average will be the relaxation time. So here you can see the definition of relaxation time, the average time of motion of electrons between two successive collisions with fixed positive ions inside a semiconductor is called as relaxation time. Now in case of drift or velocity v, let's see the diagram of semiconductor in which because of increase in temperature there are free electrons and positive ions. The free electrons while moving continuously collide with the positive ions. These collisions cause electrons to change the direction of motion. Electrons collide at random intervals, but not regularly. Electrons move randomly in the absence of electric field, but in the presence of electric field, that is this, when the electric field is applied, the free electrons experience a force and the free electrons are attracted towards the positive terminal of the battery. Now, when a semiconductor is subjected to an electric field E, each electron experiences a force, and this force we can write as F is equal to minus E into E. The minus sign is given because electrons are going to flow towards the positive terminal of the battery. It is opposite to the conventional flow. So here where now in this equation small e is nothing but charge of electron. This is charge of electron, and capital E is the electric field. Capital E is the electric field. Now this electron acquires an acceleration, and the acceleration can be given as A is equal to F upon m, where if you substitute F as minus E into E, then A can be written as minus E into E upon m, where m is the mass of electron, where m is the mass of electron, mass of electron. Now the average time between two consecutive collisions, we know that it is known as a relaxation time of electrons, and that can be given as T is equal to T1 plus T2 plus T3 plus dot 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 upon n. So this can be the relaxation time. Relaxation time. Okay. Now here, as we know, the equation of a velocity v is equal to u plus at, where v is equal to the final velocity and u is equal to the initial velocity. Then the drift velocity can be given as, okay, so here we can take v is equal to v1 plus v2 plus v3 plus dot 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 plus vn upon n. So this we can give drift velocity as v is equal to, we can take this as u1 plus u2 plus u3 plus dot 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 plus un, this u, and plus a into, we can have the t1 plus t2 plus dot dot dot, this whole upon n. So here, because the initial velocity is 0, we can write this equation as 0 plus a into t1 plus t2 plus dot 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 upon n. Now this is nothing but v is equal to 0 plus a t, where t is the relaxation time, and since a is equal to minus e upon m, we can write v as minus e upon m into t. So this will be the expression for the drift velocity. Now this expression will give us a chance to think. This expression allows us to analyze that when temperature increases, what will happen. Now here we can see the average velocity of electron in presence of electric field is called as drift velocity, and it is denoted by v is equal to E, that is small e into capital E into t upon m. So that is nothing but, we can say it is charge of electron into electric field into relaxation time upon the mass of electron. So according to this drift velocity expression, the relaxation time is the time interval between successive collision of an electron, and on increasing the temperature, the electron will move faster and more collisions occur quickly. Hence, relaxation time decreases with increasing temperature. This is an important factor. As the temperature increases, relaxation time decreases, and therefore the drift velocity also decreases. So here, if you see in this expression, if you increase the temperature, the relaxation time, that is this factor, will decrease, and because of that the drift velocity also decreases. So hence the second factor, that is the drift velocity, will decrease with increase in temperature. Therefore, in this question, that is an electric field is applied to a semiconductor, and if the number of charge carriers is n and the average drift speed is v, if the temperature increases, what happens? So therefore, when the temperature increases, the number of charge carriers n will increase and the drift velocity v will decrease. So option 2 is the right answer.